Problem number 6, everyone's favorite, right? Series problem. So I've got the series, which I never actually wrote down. Sorry, I'm going to squeeze it in here. -1 to the n plus 1, 2 to the n over n, x minus 1 to the n. I'm going to need that maybe a little bit later. The first question was find the radius of convergence. It's been a while since we've done this one. So remember, we just do a ratio test. So it's the n plus first term. So I just plugged n plus 1. Forget about that. We don't need the alternating part. So n plus 1, n plus 1, n plus 1. Divided by the nth term. So I just inverted and multiplied by its reciprocal. N over 2 to the n, x minus 1n. 2 to the n plus 1, 2 to the n leaves me with a 2. X minus 1 to the n plus 1, x minus 1 to the n leaves me with a x minus 1. And then I got an n and n plus 1, top and bottom. Powers of n are the same. We're doing a limit as n approaches infinity. Powers of n are the same, so I'm just left with a 2 times x minus 1. That 2 times x minus 1 has to be between -1 and 1, divided by 2, which means x minus 1 has to be between -1 half and 1 half. I can stop there to find the radius of convergence. You know, typically we would add 1 to both sides and you'd get 1 half and 3 halves. If we had to check endpoints, or if they asked for the interval of convergence, we would need that. But since they only need the radius is just from the middle, which is 1 out a half. So I can kind of skip that last step. Part B says, so that's a very, very straightforward interval of convergence problem that will not be on the AP test, but you might see a problem like that on my final because we've done a lot of those. Part B says, find the first 3 non-zero terms and the general term of the derivative. So the first thing I did was just write out the first 3 terms. So I just plugged in 1, got this, I plugged in 2, I got that, and I plugged in 3, and I got that. So that's the first thing I did was write out the first 3 terms. And now I just find the derivative. So I just took the root of that, which is 2, drop that power, I get 4, drop that power, I get 8. And then I just wanted the general term also. I can come here to find the general term, just take the derivative. This is all just a constant, so I just drop that power. So that n cancels with that n, gone. And then I just get x minus 1 to the n minus 1. And I still have that 2 to the n floating around. I think those first 2 problems were pretty straightforward. This third one is the twist at the end, which you probably won't see on this year's test, I don't think. It says, this series right here is actually a geometric series. So figure out what the geometric series is for f prime. Sorry about that. Figure out what the series is for f prime using our geometric ideas, and then find f by integrating. So the first thing I did is, okay, this is a geometric series. It's got a first term of 2. And it's got a common ratio of, we're multiplying, notice we're multiplying by a -2 and an x minus 1 each time. So the common ratio is -2 times x minus 1. So it's the first term, -2 over 1 minus the common ratio. And I just did a little simplifying, and I got 2 over 2x minus 1. So that's f prime. They asked me to use that to find f, so I just integrated this. And there's a quick little u sub, and I got natural log of 2x minus 1 plus c. You got to remember that plus c, we're going to get lucky because that plus c is going to be a 0. We know the initial condition, f of 1 equals 0, if you just plug in that 1 right there. So f of 1 makes the whole thing 0, right? So that means 0 equals the natural log of 2 times 1 minus 1, or natural log of 1, which is 0 plus c. So c turns out to be 0. And you get the natural log of 2x minus 1. So pretty good little twist in this last problem, but hopefully the other ones, you've kind of seen those before. Pretty similar. So that's number 6.